Hyper-dense small cells. Now, cells will become smaller. Obviously, those only three ways to increase the throughput: spectral efficiency, and the cell. So we're going to get cells are going to be smaller and smaller and smaller, and they're going to become denser. Denser means density. How many cells in a kilometer, right? Hyper-dense. And so that would be called HESNets, heterogeneous and small cell network. Previously, we had heterogeneous because there were one or two small cells. Now everything is small. And self-organizing, so we need all those things that we talked about. It has to be self-organizing because there might be somebody's building, somebody's null, and so on and so forth. And they might be going through DSL in the backward direction, in the backhaul direction, by home wireless. Mobility management. Now, if they go from my cell to your cell to that cell, we have to have all that mobility management. There's a lot of work to be done there. Forward handover, you have to hand over, right? And load balancing, and forward handover simply means that we do it in advance. So when I know that the user is moving from here to there, tell the other cell in advance, look, he's coming, and here is the keyword, password, certificate, everything for this guy. So get in. So that is forward handover. Load balancing between small cells and macro cells, and multi-rep management and everything else. The thing is, these cells might be privately managed, privately owned as well. Mall may own them, hospital may own them, so on. Yeah. This slide what? New efficient. Intelligent multi-mode. Okay, I forgot to put it here. Okay, all right, 10. Maybe actually 11. All right. So the next one is, ping pong. Okay. Ping pong is when a user is standing between two cells equally distant, then it cannot decide which one to connect to. It will try this one and then say, oh, no, that is better, than try that one and then try this one. And that is called ping pong, table tennis. All right. So now there are four techniques for energy savings. I got to go a little faster, sorry. First is that do not transmit. All right, when you are not doing anything, you have nothing better to do, sleep. Don't waste your energy. Then there is antenna muting. This is again very clear. Basically, you don't have to use 8x8 MIMO all the time. When the traffic is low, just turn off the 7 antennas and just do one by one, right? And cell on-off switching. In the night, if nobody is walking around, just turn off the whole thing, right? And so the question is, if somebody did turn off, what happens? So every few seconds you wake up and say, oh, I'm here. And so they know that you are there, right? But most of the time you are sleeping. This base station is sleeping. Right now they don't. But with this one they will do. Now what are the techniques to reduce the dollar sign? Right? CapEx and OpEx. Capital expenditure and the operational expenditure. Right? So SDN, NFV, NEC, and CRAN. SDN basically is software-defined networking. How many people know here software-defined networking? Okay, so those of you who are not raising their hands are not listening, do you know software-defined networking? Have you heard of this word? Basically, what it means is three things. First of all, that you don't worry about this exact hardware because you just use a standard standard programmability thing, right? So you can program anything remotely. That's how it means really. Program anything remotely. So you have to have 1,000 routers. You just can send a command and all 1,000 will understand that now you need to shut off. Now you want to shut off, change the parameter, whatever, right? And centralized control because you're going to do it from the central one place. And so that will be used in the 5G. All right? And the main savings is that orchestration. You can do thousands of base stations, thousands of light cells, small cells from one command. Right now you need a lot of operators to operate each cell. With software-defined networking, you don't have to worry about it. Network function virtualization. Now, NFV is a concept where they're saying, why don't we use the cloud for everything? Why do we have to have this expensive hardware? Right now, if you go to a data center from a carrier, they have $1 million machines. Some do remote RNC, which is remote network controller, and some do IMS, NME. We have all these names, mobility management. And these are all specialized hardware and very expensive. Just forget all this, put it in a virtual machine and put it in a cloud, like Amazon or our own cloud. And it will be very cheap, and you can create as many as you want. So that is called network function virtualization. All these functions will be in the cloud. Then the third concept is MEC, mobile edge computing, is that every user needs computing to be done, and cell phones in particular. So why don't we bring it to them rather than everybody going to the cloud, which is far away? So they will put a cloud on every tower. Yeah. Yeah. So the fog computing really says that computing everywhere. So it doesn't talk about the cloud as such. Okay. Fog computing means that my cell phone, your cell phone, their cell phone, refrigerator, everything is doing computing. That is fog computing. And cloud computing is obviously opposite of fog, right? I mean, fog is on the ground, the cloud is in the sky. So the cloud computing means that you have an organized set of machines which are being shared by different people. That is cloud computing. And this is mobile edge computing. So basically, this is the clouds have been put on the tower for people to share. So you can have, I mean, strictly speaking, you don't have to have fog computing. You can do MEC. And if you have fog computing, MEC will work with that too. You know. So this is MEC, is that putting the cloud on the tower. Finally, CRAN, Cloud Radio Access Network. So they said if they are going to put everything in the cloud, why don't we, and centralize it, SDN, NFV, why don't we do that to apply that to the radio network? So basically, right now, the antenna is on the top. On every antenna base, there is a small hut where they keep the baseband unit. Remember that baseband unit we talked about? Intermediate frequency and the baseband, etc., etc. All that logic is kept in that hut. Right? And if you have 1,000 towers, you have 1,000 huts. In case of small cells, there is a small box. It does that, right? So they said, why don't we just take all of those DBUs and move them into a central place in a cloud? So these things are called remote radio head, which is the antenna, which obviously you cannot put into a central place. The antennas have to be distributed, but everything else you take it to the cloud. Right? So this is called Cloud RAN, Cloud Radio Access Network, CRAN. And the main problem is that this is very high frequency signal, which you are taking from the antenna and taking it to DBU. Right? So generally you need 10 gigabits per second, either just a fiber optic line or Ethernet or something. Okay? And so you take all those bits over there and then process it over there.